Alright, here's just a little review of angle pairs. This is coming from section 1.5 in the Glencoe textbook. But what I want to focus on are just angle pairs. And to start off, let's look at these four terms. And I'm going to make this creative by putting stars by the four. Star, 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 and star. So first of all, adjacent angles. Adjacent angles here. If you look at them, they're two coplanar, so they have to be in the same plane, angles with a common side, a common vertex, but no common interior points. So if we look over to the side here, I'm going to pretend that this is our plane, even though planes go in all directions forever, but this is a plane. They're all in the same plane, these angles. Do they have a common side? Yes, angle 1 and 2, this is their common side. Do they have a common vertex? Yeah, right there in red. So if you look, they have a common side, a common vertex, and if they have no common interior points, which if you look, they don't, angle 2s are all over here, angle 1s are all over here. There's none in common. I'm not sure how that moves there. There are none in common there. So that means that they are adjacent angles. Similarly, this one over here, the first one, as you notice, it'll add up to 180 because it's a straight angle, the whole thing, which is nice, but they're not going to always be that way. We can look at this other one and say, does this one have, it's all in, is this in a common plane, which yes. Do they have a common side? Well, I can show you in green here. Yep. Do they have a common vertex? You got one in red there. So definitely. And if you look, there's also no common interior points. So these are all the blue ones, and these are all the purple ones for number 3. None of them are common. So that means they are adjacent angles. All right, second term, vertical angles. These are very helpful angles. We're going to use these a lot. Vertical angles are two angles whose sides are opposite rays. So for instance, we'll say angle 1 and angle 2 are vertical angles. Angle 3 and angle 4 are also vertical angles. And I'll show you why. If you look at angle 1 and angle 2, this is one of the sides for angle 1, and its opposite one is right over here. It's the opposite. It's the side for angle 2. Same thing here. This is the opposite of this. And if you look, those sides, they're opposites, but they're all on one line. That makes up, it's two rays that make up one line. So that means they're opposites. If it was something like this, so let's say I have this, and then I have like that. These two angles would not be opposites, or they would not be vertical angles, because this side here is not the complete opposite of this side here. So that's just a counter example. But this one would be. We know that angle 1 and angle 2 are vertical angles. Angle 3 and angle 4 then are vertical angles because they're opposites. And we'll find out later on that angle 3 and angle 4, they look the same, and they actually are the same measure. Same thing with angle 1 and angle 2. So that's a nice thing about vertical angles. So there are vertical angles. Complementary angles are two angles, and complementary and supplementary should be reviewed. These are things that I don't know when you learn them, but the hardest part here is keeping them which one is which. Complementary angles add up to 90 degrees. They're two angles that measure add up to 90 degrees. They should make what would, if they're together, they should make a right angle, which like this one does, right angle. So there's two angles, and angle 1 and angle 2 would be complementary. This one here, 47 degrees, and this one here, 43 degrees. We know that they're complementary, sorry, because they add up to 90. 47 plus 43 gets you to 90. Even though they're not right next to each other, they're still considered complementary angles. And then supplementary adds up to 180 degrees. So we have our straight line here. That means that everything over here is going to be 180. So this angle plus this angle would add up to 180. And this other example over here, it's not complete because it's only 137 degrees. But if you wanted to complete it, you could complete this line. And then this, we could figure out that the supplement of it would end up equal to 43 degrees. (43 degrees) plus 137 degrees would get you to 180 degrees, and that's really important here. And if you look down here, there are a couple examples that we went through in class, but just to reiterate, it says, is this true or not? Let's look at the second one, B here. AFB, angle AFB, which is right here, angle AFB, and angle EFD, which is EFD, are vertical angles. I'm going to say no. And the reason why here is because if you look, these two, AF and FD, are actually opposite sides. But if you look over here, this does not look like it's the opposite of that. They're not perfect opposites, so they're not vertical angles. They have to be perfect opposites, making a straight line. If it continued here, this would be the opposite. Angle AFE and angle BFC. We're wondering if those two are complementary. Yes, they would be, because 62 plus 28, if you add it out, carry the 1, you'd get to 90 degrees. So this one is a no, but this one is a yes. And if you want to check, I believe this one was a no as well. We are going to, I'll check the time here. We are going to go on to a little bit of additional stuff that we did not cover yesterday, but they are in your notes. So you can fill these in your notes if you would like. There's going to be lots of color on here. So just so you know, it says if measure of angle 3 is equal to 2x plus 5, and I'll add that in there so you can say measure of angle 3 is 2x plus 5 degrees. Measure of angle 1 is equal to measure of angle 3, so we can put this little circle, or this little arc in there, because those two are equal. We can also say that that is 2x plus 5. Sorry. And measure of angle 2 is 2x plus 20, so I'll put that in red. 2x plus 20 is right here. What is the measure of angle 1? That is the question. So we're trying to figure out, we know it's 2x plus 5, but I want to know actually what it is in degrees. So what do we know here? It looks like we know that this whole thing here, line AD, is a line, so it's a straight line. So that means anything over here would be 180 degrees. Also, anything over here would be 180 degrees. Because straight angles make 180-degree angles. So we're looking at this side here. Why don't we add them all together? Those three angles together should add up to 180 degrees. So let's try that, and I'll put that in black here. Well, we'll say 2x plus 5 plus 2x plus 5. We have angles 1 and 3. We need angle 2 yet. We'll do that in red. Plus 2x plus 20 would get you equal to that grand total of 180 degrees, because it's a straight angle. Now we're just doing algebra. If we can solve for x, we can figure out what the angle measures actually are. So based on the associative property, these groupings here, we can either move them around however we want, or we can get rid of them because it is all addition. So let's just get rid of them and know that 2x plus 2x plus 2x is 6x. And then 5 plus 5 plus 20 gets you to 30. And that all equals 180. Then you can do a little algebra, subtract 30 from both sides. You'll end up with 6x equals 130. 150 degrees. Not degrees, sorry, just 150. And then x equals, you divide it by 6 to get x equal to 25 degrees. 150 divided by 6 gets you to 25 degrees. So that's something worth knowing. X equals 25 degrees. But are we done? Does it ask us what x is? I don't believe so. It's asking us here what measure of angle 1 is. So if we know that the measure of angle 1 is 2x plus 5, we can plug in 25 for that and say 2. That's weird. Where at? We're going to leave it at blue. We'll say that 2 times 25 plus 5, and that'll be 50. Got to do multiplication first. Plus 5 equals 55 degrees. So that answers our question. Measure of angle 1 equals 55 degrees. And since it's also equal to the measure of angle 3, we know that the measure of angle 3 is 55 degrees. And you can either plug in this 25 for the measure of angle 2 for x here, or you could know that 55 plus 55 plus whatever this is has to equal 180. And so 180 minus 110 gets you to 70 degrees. So there's your 3 angles. It only asks for 1, but we got all 3 of them really quickly. All right. So then our closing question, how can you remember that the sum of the measures of complementary angles is 90 degrees? So complementary is 90, and supplementary is 180. That is the question. You can look things up. You can come up with your own acronym. The way that I've always remembered is that supplementary, I guess from that supplementary I think of super, and the super angles are going to be bigger than just the regular angles, the regular complementary angles, so that's the bigger one. Some people also look at the first letter. So C comes first in the alphabet, and 90 comes first when you're counting. S comes second in the alphabet, and 180 would come after after 90 when you're counting. There's just different ways of looking at it, and it's just up to you to make sure you can remember that. Now, the last part I want you to look at here is some error analysis, figuring out what the errors made and fixing it. So the question says, use the diagram below. What is an angle described by each of the following A and B? And you explain their reasoning. So this person here determined that supplementary to angle REQ, so you have angle REQ, supplementary to that would be YER, and I'll use purple for that, YER, based on the fact that GEY is 90 degrees and so is YEQ, so that's also, those are right angles, so they add up to 180 degrees. But then we know that YER and REQ add up to 90 degrees since this is a right angle. Makes sense, right? This whole thing is a right angle, so the two would add up to 90 degrees. But what's wrong with that? Oh, if you remember supplementary angles, supplementary must add up to 180 degrees up there. So this would have to be complementary, either complementary to that would be YER, or you could say a different angle would be supplementary. You could say that GER would be supplementary to REQ. Now let's see if the other one is backwards as well. I'll erase this. Complementary to TEG. So if we're looking at TEG here, TEG, we want complementary, and they're saying that it's TEQ. TEQ. Looks like those are going to be supplementary instead of complementary, so I'm going to erase that and say supplementary. I think that's a mistake already. Because it's a straight angle, it adds up to 180. we know that supplementary angles add up to 180, whereas complementary add up to 90 degrees. So that's very important to see the difference there. Now what I want you to do after watching this video is make sure you're using your notes and work on worksheet 1-5. So it's all about section 1-5, all about the angle pairs, and it'll be great practice for this section. Until next time, have a good one.